Good afternoon, everybody. I'm Kaloyan Kotlarski. I am going to talk about how we tackled automated CloudStack deployment at StorPool. A little bit information about me. I'm currently 26 years old. I work as a system administrator in our technical support team. Since we're selling a managed service, we have a quite large department of people who take care for our customers' deployments. And when I have, let's say, spare time, I seldomly pick DevOps tasks like this one to help my quality and automation team. So today, what I'm going to present to you is our approach to this thing. Before I actually was tasked with creating automation that would help our developers, our solution architects to have disposable CloudStack environments. I did an extensive research and I found an old article that was targeting, if I recall correctly, CloudStack version 4.13 that had some sort of Ansible automation, but at the time that didn't look really useful. So moving forward. Now, why did we have to do this? Since StorPool is a storage solution, we offer integration with CloudStack, and this integration requires, for older versions, manually recompiling the entire CloudStack code base and integrating our driver so that our code can reach both the CloudStack management and the CloudStack agent. And since we offer support for different versions of CloudStack, our developers had to switch constantly between different versions so they can make progress and validate their changes in case they're not breaking stuff. As well as we wanted to have automated testing. This is something really important. So we needed a means for our continuous integration system to be able to provision CloudStack environments on the fly. And last but not least, our solutions team, when designing POCs or future solutions for potential customers, wanted to be able to have disposable CloudStack environments like a snap. So these are the main reasons that we decided we would invest time and effort in developing an automation. It has grown more than just an Ansible playbook and a set of Ansible files, so that developers and other people can have reproducible CloudStack environments. Now, a bit of side note, a bit of side story. Me personally, I come from the OpenStack world, and I have, let's say, experience with different automation tools that OpenStack uses to deploy itself. I'm not going to go into them, but some of my decisions, some of my point of view is influenced, and I have inspired myself to for certain decisions about systems that OpenStack uses to deploy itself. Just one last word. OpenStack is immensely more complex when coming to deployment in comparison to CloudStack, but still there are some patterns that recur. There are a lot of things in common, and yeah, I'm finishing with this side story. Now, this kind of covers, why a deployment should be automated. Can't we just follow the install guide and be done with it? Yeah, we can. Though this saves efforts and it allows developers to self-service them in a way that, let's say, if I'm a developer, I imagine that I don't want to be bothered with infrastructure. I don't want to be bothered with deployment, with networking, compute instances, so on, so on, so on. I just want to write code, but this requires the proper environment in which I'm going to create code, in which I'm going to test the code. So I was imagining that if I'm a developer, I just want to have a system, have something that I'm going to tell it, okay, here are your parameters. Now give me something that I can work with. And I think this is really valuable for developers because it helps them focus on really solving problems, writing quality code and not having and not wasting their time in doing side tasks. And of course, it integrates with a continuous integration system. We use Jenkins, and that helps it trigger automatically the integration suite. So what is the general picture of our approach? We have, let's say, 3 main components that constitute this entire system. First thing is infrastructure as a code solution. Since in our infrastructure we use OpenNebula, I picked OpenNebula OneFlow, which is an infrastructure as a code solution similar to Terraform, to AWS CloudFormation, OpenStack Heat, this sort of thing. You just describe all your infrastructure in a machine-readable format. You give it to this piece of software, and by the means of the cloud, it provisions the infrastructure for you. Next, we need a cloud management system, configuration management system, sorry, which we picked Ansible. This is the major and the only configuration management system we use at StorPool. We like it because it's agentless, it uses YAML and Python. So these were pretty much the requirements that we posed on the configuration management system. Furthermore, we use Ansible as well for deploying StorPool, so it seemed like a natural fit. And the third thing is what I called an automation platform. We're using AWX. This is the upstream version of a product by Red Hat called Ansible Automation Tower. It's now rebranded as Ansible Automation Controller. Basically, this is sort of a smart system that augments Ansible's natural capabilities, like having a centralized inventory, having a place where you can have sort of authentication, organizational control, having it centralizes all of Ansible work, all of things that Ansible is used for in an organization. We picked it because other competing systems to Ansible, like Chef and Puppet, have such things more like a built-in way, so they come packed in the box. Ansible does not come in this way. So moving on to the next slide. Who is doing what? So I briefly touched what OneFlow does. I'm not going to go over it again. To me, it's pretty self-explanatory. Now, we have a piece called CloudStack Automation. So this is a set of Ansible playbooks, roles, tasks, which follow to a great extent the CloudStack installation guide. So they reproduce the steps, but in an automated way. And we have its current status is to somewhat deeply integrated with StorPool and the way we work internally and we test it, but there is a lot of code that can be reused to your will, can be adjusted or modified to suit your needs. And lastly, AWX, which orchestrates the entire process. So AWX is sort of the, the brains behind the whole thing. We described there which step is first, which is second. Upon success of one task, follows the other task, and so on, so on. I'm going to show you how it looks like, how it feels like. And why did we choose AWX? So these are one of its key selling points that we thought are important for us, that we find useful. It has an extensive API as well as a web user interface and a CLI. So the main idea was to let developers in a particularly easy way to have an environment to work against. So this is how the whole thing works, now broken down into individual steps. So the first step is we spawn an OpenFlow service. So this basically tells OpenNebula, the cloud, okay, I want instances, I want networks connecting them. Then we perform an initial host bootstrap, which is basically disable the firewall or do EOM update, stuff like that. That's common to all the hosts. Then we build CloudStack from source, because we have to. Then we set up an RPM repository on the host that is going to be the management. Another thing, some of the decisions that we made are sort of quick and dirty work. They're not perfect, and they are subject to being refined, to making them, to having more abstractions, so that people are free to work and to reuse this thing in the best way they see fit. And we have targeted as a start the Red Hat family. So this is CentOS, Alma Linux, Rocky Linux, RHEL, etc. So it sets up an RPM repository where it places the RPMs that got built from building the CloudStack source. It then installs all the prerequisites on the management host, that is MySQL database, NFS exports. It then installs, of course, the CloudStack management package. It bootstraps CloudStack, so does the initial database bootstrap, downloads all the system VM images. After this, it configures zones, pods, clusters, physical networks, all the stuff that's required for a CloudStack deployment to get running. It then moves on to installing the CloudStack agent on the hypervisor hosts and configures networking and the required virtualization package on the hypervisors. Next, it adds the hypervisors to their respective cluster. And last, this step isn't done yet. It configures primary and secondary storage so that the end deployment is in a state that is fully usable, so you can spawn virtual machines. And let's not forget, a developer can work against. So it's in a state that is expected for developers to start work. So this is a little bit of technical details. I'm going to go briefly. All of this you can find in the repository. The link is in the end. So whoever is interested can check this out. For us, this, as I said, this step is mandatory. And what we found out is that building CloudStack is cumbersome and slow. We tried to optimize it as much as possible, and we got it down to 15 minutes. That is from checking out from source and building it to RPMs that are ready to be distributed to the end systems. And since this takes a lot of time, and my strive was to have the playbook as idempotent as possible. That means run it no matter how many times, and the end result is the same. If the playbook detects changes to the source code, if there are no changes, it skips the entire build process. So you just carry on with installing the packages. Now, this was, again, particularly interesting. It turned out that CloudStack may override its database, and if you try to bootstrap repeatedly the database, you can get locked out of your deployment because it changes credentials. So I had to find a way to do this only once, no matter how many times the playbook is executed. So we place a shadow file that it's the presence of the shadow file indicates that the database has been bootstrapped, and you can safely skip that step. And last but not least, I found particularly fatiguing, I might say, the initial work of configuring CloudStack once it's been installed. So what we do is we kind of tell the playbook that we have a plan. So you're going to have this much zones. Each zone is going to have this much pods. Each pod is going to have this much clusters. They are related in this way. Please configure them for us. So we, before moving on to installing agents on the hypervisors, we actually do all of this, and it's again, idempotent. So these are API calls to the CloudStack management API. So if it detects changes, you're going to see in the demo, and if everything is okay, it just says, okay, everything's fine, everything is as you want it. If it's not, then it changes stuff that are not the way you want them to be. Okay, so demo time. So this is the AWX system that I talked about. You can, by default, it runs in a Kubernetes cluster, but I believe you can have a sort of a demo of Docker Compose. Now, I log in with Google because we have Google Workspaces at StorPool. But you can have other social backends, I believe GitHub, Microsoft, and others. So here in templates, actually, I might. So no. Let's first see how our automation repository looks like. So this link is in the presentation as well. I'll share it with you. The repository is public. So this is how our repository looks like. And as you can see, there are currently four, pardon, for playbooks. Let's say this one looks like so. But that, I guess, that's not the most interesting. The most interesting is this one, which is, to a certain extent, pretty straightforward. Now, each of these playbooks can have to be defined as a job template in AWX. So let me filter those. So as you can see here, it says job template. If I say, click here, you see that it uses this playbook. So what this means is that I can now launch this job template against an inventory, and all the tasks defined there, as a standard Ansible playbook would be executed against this inventory. Now, the cool thing about job templates is that they can be, say, unified or orchestrated against what is called a workflow. So a workflow is a workflow which can have multiple. It can have multiple job templates or inventory syncs or any other steps tied together and executed on a certain condition. Now, what you're seeing in front is basically, it basically says, okay, now provision the infrastructure, then retrieve what you have provisioned, build off an inventory, an Ansible inventory, bootstrap all the hosts. That means do actions that are common to them. And then we have two jobs that are executing in parallel. One is deploy CloudStack. The other one is deploy StorPool, which this one is specific to us. You can have anything else here. And when I actually go here and I click launch, it would show me this thing, which is called a survey. A survey is a form where you can have predefined parameters that have to be filled in by the person who is launching the template. So I have some here that are mandatory for the whole thing to work, but you are free to create your own surveys, to incorporate your own parameters, etc., etc. And if I go here now, I'm going to launch one for you. So we want the test one. This is the old default. We want this. Oh, damn it. okay, it's going to survive. And say we want Rocky Linux 8. I click next, so I have a brief summary of what it's going to do, and I hit launch. So now it starts executing all the job temp, all the workflow as defined. And if I want to track the progress of a job, so yeah, something that I forgot mentioning is that job templates give birth to jobs, yeah, in case someone hasn't figured it out yet. So currently it's in provision CloudStack infrastructure. And so this is a regular Ansible playbook that gets executed. And right now, Ansible is talking to OpenNebula's one flow. And if I move to the window here, hit refresh. It's taking some time. See, we have a new service that is in state deploying. If we move over here, we have some VMs that are currently being deployed. I have a warning sign here. So while the whole thing is bootstrapping, I think is a good time to move to Q&A. If anybody has a question, I would be gladly answering it. Yes? The red button. Hold it until the, yeah, should be on now. A couple seconds, it needs to sync. So I'll repeat the question. What would it take to change the infrastructure as a code solution that is currently used? You simply have to create, let me just move over here. So this is the same source code. You would need a playbook like this, which talks to the cloud, and it tells the cloud, well, create me this and this infrastructure. You're not in any ways tied to OpenNebula OneFlow or anything else. You can bring, say, AWS, OpenStack Heat, Terraform, etc., etc. The important thing is that you'd be able to, when the creation of the infrastructure is done by the cloud, you need a way to let AWS collect the information back. So AWS has to be made aware of the resources that you've created. This is done with a concept that is known in Ansible as inventories. AWS builds on this concept of inventories by using what's called sources. Now, sources can be static YAML files, they can be, or where you describe how your infrastructure looks like and how Ansible should connect to it, or it can be used, or you can use plugins, cloud plugins. These are basically Python modules that AWS uses. It connects to the cloud, it retrieves the information, and then builds the inventory from it. Here we are using the OpenNebula plugin, but there are plugins for CloudStack, for OpenStack, for AWS, for GCE, for like most of the major clouds that are either from the hyperscalers or on-prem, whatever. So this is the second important step, so that you construct the right inventory. Once you have provisioned it, you have to construct the right inventory. And here you see what currently AWS has imported from our OpenNebula instance. Does that answer your question?
Thank you. And another one coming online.
Yep.
Does this solution work for all hypervisors other than KVM?
I cannot tell because we have tested only with KVM. I see no real obstacle for using other hypervisors. Since we at StorPool focus on Linux deployments mostly, it naturally comes to be KVM. We haven't tested with anything else yet. Just something else to mention, this project, as you see, is heavily work in progress, but everyone is welcome to check it out, to submit a pull request if you like, kind of bring in the open source spirit.
Thank you. And another one coming online. Are you deploying ACS on OpenNebula VMs, or is it Metal?
It is OpenNebula VMs. We find it easier to play with virtual infrastructure because it's faster, it's more easy to wipe it out if something has failed or if you want to have it in another way. In theory, as long as you have the proper infrastructure as a code solution, first thing that comes to mind is MAS by Ubuntu. You can have the same thing on bare metal. It should work out of the box.
And another one. Can you show your solution of avoiding redeployment of the database through a shadow file in short?
Yes, I can. So moving on here, some of these roles are, let's say, are related directly to StorPool and to the way we integrate with CloudStack, but the one in question is purely CloudStack. So we have a role called CloudStack Management. Now, the point of this role, its purpose is to, you give it a host, which you designate is going to be the Apache CloudStack Management host, and then it installs the package that you've built. It can actually install a package that is, so let's say a step backwards. If you configure the yum or apt repository for upstream CloudStack packages that are pre-built by the CloudStack community, you can easily use this role. So moving on to the database part. Let me just close some stuff really quick. It's somewhere, yeah, it is in here. So if you see, we have initialize CloudStack. Yep, I'm going to, just a sec, to zoom in. I can't, just give me a second, please. Give me a second. So I'm going to move the code just to be better. So what this does is calls the CloudStack setup databases file that comes pre-built with CloudStack. Now here is the important part. Creates and the creates keyword tells it basically that after this command has been executed, it should create a file. And when you try to execute it again, if the file exists, then it would say, okay, the command has been run, I have nothing to do. Also, please pay attention to this line. It says, notify setup CloudStack management. This is what is known in Ansible as a handler. So a handler is a specific task that gets executed only if the main task, so this one, has been changed. So let's see what the handler does. So each handler, so in a handler you actually have multiple tasks that can listen to the same topic, pasting this one. And as you can see, we have listen, set up CloudStack management. So when this command runs and Ansible detects a change, it would execute this task as well, which would create a file by the specified path. This is a variable, so you can customize it. It has a default, but you can put it wherever you want.
Yeah, thank you. Another one coming online. How does this compare to something like Trillion, then build your own? Are you aware of Trillion?
I'm not aware of that
so
technology.
Trillion is a automation tool built specifically for CloudStack using Ansible as well.
I haven't met with that tool.
I guess. Okay. And another one, why not CloudStack VMs instead of Open Nebula to launch the VMs?
We actually are using Open Nebula VMs that pretend to be real hosts.
I see, okay. Cool, any other questions here?
Did you have to write any custom plugin to Ansible to perform that automation, or are you resorted to publicly available plugins in the Ansible ecosystem?
I try to resort as much as possible to publicly available Ansible code, that is roles, that is plugins, collections, everything that is in the Ansible ecosystem I try to use as much as possible, because personally I have the mindset that if something out there is working and is doing what I need, I'm going to use it. I don't want to reinvent the wheel.
More questions? I'm sorry, were you going to do a demo, to continue with the demo? Or?
Yeah, the demo should be running in the background. Let's see, where did it got to? I just wanted to skip the cloud deployment stuff. So let's check on our virtual machines. So all of them are running. And as we see, the Bootstrap job runs successfully. The deploy StorPool job runs successfully as well. Now, the deploy CloudStack job is currently running. It's holding its output. And if we scroll down, So this is preparatory steps. Now, another thing that I had to do is have dynamic in-memory Ansible inventory. So this is inventory that gets built on the fly. What this gives you is greater control of grouping and assigning host variables to hosts in Ansible, because this is a key concept of how Ansible is working. If you don't have the correct inventory, the way you're going to have a hard time. So, by the way, the code is here. No, sorry, that's some old stuff. Is here. So I'm going to go over it because CloudStack is currently, if I'm correct, yes, it's building itself. So I'm going to go over this code. Generally, what this does is, see, I have creating CloudStack management group, so I can reference all the hosts that are going to be, that I want to be CloudStack management by like a common name. Grouping is an essential part of working with Ansible. So if you create the right groups, you can then pretty easily map tasks to those hosts in those groups. And this is like half of the magic. Why does it work so simple? Because in later playbooks, I have, just let me move here. If you can see, I'm just going to copy this fragment. No, actually, I'm going to copy this one. As you can see, I just say, okay, I want all the hosts that are CloudStack managements to have the role of CloudStack management. And inside the role, I have put all the tasks that are relevant to actually bringing up a CloudStack management. So this is one of the reasons why if you scroll up, this is the code that this code actually places each host in its respective group, and this is part of the design of the whole system. So because we have hosts that are part of StorPool, but they have one role as StorPool hosts, and then the same hosts have another role, have another purpose from the perspective of CloudStack. And yeah, so CloudStack is currently building itself, and it's sadly, I believe that the session will be over before it builds because it takes roughly about 20 minutes. So if it started at 28, it's going to finish at approximately 48. So if anybody has other questions, besides that, I'll be around here. So if anyone wants to see the actual outcome, I'm kind of sorry, I should have started the build in the beginning of the talk. I'll be glad to show the output and the end result.
Any questions?
Yep, there's a question.
Where do you define which hosts to be like system ones and which, from where OpenNebula knows which host to use or which not? From centralized system or manually hard-coded?
No. So this is the file that does the magic. Let me just copy it so you can see better. As you can see, I have, it says one user attribute filter. So what this means is that when the code that talks to OpenNebula's API gets executed, it retrieves all the hosts that there are in OpenNebula, and then filters out those who only have a role name field user attribute defined. So if I move, let me show you briefly. So let's pick this virtual machine. And if we scroll down at attributes, you see it has the role name field. And there's something in it, some value, doesn't matter what value. If I say select another random machine, it doesn't have this attribute. So I'm using this attribute to filter out machines that I know would be created by one flow. And then there's another round of grouping, which is the so-called, I think that's compose. So I'm adding all these host variables in Ansible by evaluating the Jinja expressions here. So this part is actually a Jinja expression that gets evaluated. And now if we move back to how AWX sees the host as a final result, say we picked this one. These are all the host variables that the host has inherited. So it's written down inside AWX inventory with those parameters. And the plugin actually helps it like figure out this one. No, sorry, my bad. These are the ones that get computed, and the rest, these ones are retrieved by the OpenNebula inventory plugin. All that stuff it's retrieved from OpenNebula's API. And then before each major part, this code further distributes them down to groups of interests based on certain parameters, because I couldn't find a way to do this job inside this file. So I decided to kind of exploit Ansible's in-memory inventory feature that allows you to group hosts and to add host variables on the fly.
Thank you. Any other questions that we have in the room? I see no more questions online. So thank you very much, Kaloyan.
Thank you all.
Great session. Applause.